we are living in an era where, an early career developer can generate, literally thousands of lines of perfectly syntactically correct code in like a matter of seconds.
Oh, yeah. And flawlessly formatted, too.
Right, flawlessly formatted. And yet, if you look closely at the industry right now, code-based fragility is actually going up.
It really is.
Code is getting harder to read, harder to maintain, and teens are just terrified to touch their own legacy systems. So, welcome to Dev Trends on the Go, today's Qiita Picks. It is June 20th, 2026, and this daily catch-up is perfect for your commute.
And for our global listeners who might not be familiar with where we actually pull our sources from, Qiita is one of Japan's most popular knowledge-sharing platforms for software engineers.
Right.
You can basically think of it as the Japanese developer community's equivalent to, like, Dev.to or Medium.
Yeah, exactly.
So analyzing their trending articles gives us this fantastic ground-level view of what engineers are actively struggling with, debating, and building right now.
And today, we are tracking a really clear narrative through those articles.
We are. We're moving from the fatigue of the front-end ecosystem all the way down to the physical silicon-powering AI data centers.
Before we get into our deep dive into the source material, though, a quick reminder to subscribe and like the show. It takes just a second, and it ensures you don't miss these daily industry insights.
Please do.
So, starting at the code level, our first article tackles this very real sense of fatigue in the JavaScript ecosystem.
Oh, the JS fatigue is so real right now.
It is. It just seems like the abstraction layers have gotten so thick that we're completely losing sight of the underlying mechanics.
Yeah, the author points out that the front-end world has become incredibly confusing, especially for new developers.
Yeah.
Because you have these libraries and frameworks constantly masquerading as full programming languages.
Right, like Next.js.
Yeah, exactly. When you rely on a web framework like Next.js, you're essentially using a tool that handles all the complex plumbing-like server-side rendering and routing, so you just don't have to build those fundamental pipes from scratch.
Which is great, but...
Right, but when that abstraction layer hides the plumbing completely, developers literally forget how the water actually flows.
Yeah, people used to use this analogy where JavaScript was the recipe and a framework was the kitchen, but that feels entirely backward now.
Oh, completely.
Like JavaScript is the fundamental ingredient now, right? The raw flour and sugar. React is the recipe, or the method you follow to bake. And a framework like Next.js is the fully equipped industrial kitchen.
That's a great way to put it.
You aren't inventing the oven, you're just turning it on. But if the oven breaks and you've never learned how heat transfer actually works, you are completely stuck.
You're frozen. And that not understanding your tools leads directly to the issues highlighted in the second trending article about coding anti-patterns.
Oh, I loved this one.
Yeah, that's so relevant. The author specifically focuses on two prevalent issues right now, which are lava flow and cargo cult programming.
Lava flow, that's such a visceral name.
Right. And the mechanism of lava flow isn't just, the presence of old code. It happens when undocumented dependencies get so tangled over time that the code just hardens into the system.
Literally like lava cooling down into rock.
Exactly. No one knows what it does, and there is zero test coverage, but everyone is terrified to delete it because it might just, break a critical feature somewhere else entirely.
See, people usually compare bad legacy code to keeping a random useless cable in a junk drawer just in case you need it.
Oh, I definitely have one of those drawers.
We all do. But a useless cable just sits there harmlessly. Lava flow feels more like, a load-bearing wall in your house that has severe termite damage.
Oh, wow. Yeah.
You know it's rotting, you know it's dangerous, but you absolutely refuse to knock it down because you're convinced the entire roof will cave in, so you just build these weird support structures around it.
That is painfully accurate. It creates systemic fragility. You end up spending way more time working around the hardened lava than actually building new features.
Right, and what was the second one? Cargo cult.
Yeah, cargo cult programming. And this has just exploded with the rise of AI coding assistants.
Oh, I can imagine.
It's when a developer copy-pastes the block of code like, say, an AI-generated React hook, and happens to compile, but they have zero understanding of why it works. They just treat it like a magic spell.
It's waving a wand.
Right. They perform the ritual of pasting the code, they see the UI render, and they just assume the software is structurally sound.
But wait, if AI is generating the code without the traditional compilation errors, how do early career developers actually learn the plumbing?
That is the big question.
Because historically, you learn by writing bad code, watching it break, and fixing it. That friction is what built your internal mental model of good architecture.
Absolutely.
If AI skips the error state entirely, beginners are completely flying blind.
You are touching on the exact friction point raised by our next source. The author argues that because the traditional trial and error phase is essentially dead, we now have to consciously install philosophy into inexperienced programmers.
Philosophy, like Aristotle.
No, more like architectural philosophy. You can no longer rely on syntax errors to be the teacher. Beginners need a core philosophy on how code should be designed, a mental model of architecture, before they even start prompting the AI.
Oh, I see.
Otherwise, they lack the critical thinking required to evaluate if the AI's output is actually robust or if it's just a house of cards.
That makes a lot of sense. So you mean if the AI is handing you perfectly formed bricks, you still have to be the architect.
Precisely.
You need to know if you're building a shed or a skyscraper, because frankly, the AI doesn't care.
It doesn't. It just gives you bricks. And we see this dynamic playing out at the very top of the industry, too. Another fascinating piece dissects Microsoft CEO Satya Nadella's current strategy for enterprise AI.
Oh, interesting. What's his take?
Well, the article contrasts his approach with this brilliant analogy from the Japanese TV show Grand Maison Tokyo.
Okay, for our global listeners, Grand Maison Tokyo is a highly popular Japanese drama centered around a Michelin star chef striving for absolute culinary perfection.
Yes, thank you for the context.
I am always here for a Michelin star cooking analogy. So, how does a high-end kitchen relate to Microsoft's AI deployment?
So, the author notes that Nadella's enterprise strategy is heavily focused on extracting a company veteran's expertise into a corporate AI loop.
Okay.
The goal is for the AI to learn the specific workflows, the best practices, and the recipes of a company's top performers. But the Grand Maison Tokyo analogy points out the hard limit of this approach.
Which is what?
Well, a master chef can meticulously write down their recipe, right? And an AI can replicate that recipe with mathematical precision. But when a customer actually sits down in the restaurant and eats the dish, the AI cannot take human responsibility for that experience.
Right. Because if a customer has a severe allergy or if the local ingredients that day are, I don't know, slightly more acidic than usual, the head chef has to taste it, make a judgment call, and actually own the outcome.
Exactly. And AI doesn't have a reputation to ruin.
Yeah.
It doesn't get paged at 2 a.m. when the production database goes down.
That is such a good point. So the value of a software engineer is shifting entirely.
It's moving away from the manual labor of just typing out syntax and moving toward commitment, taste, and ultimate responsibility.
So you are no longer judged on how fast you can chop the digital onions?
Right. You're judged on whether the final architecture is secure, scalable, and actually solves the business problem.
But taking responsibility for a production system requires a deep understanding of the infrastructure running all of this AI code. I mean, you can't just run an enterprise AI loop off a laptop.
Definitely not. You absolutely need the right structural foundation, which brings us to a highly discussed article comparing the architectural mindsets of AWS and Microsoft Azure.
Oh, the classic cloud rivalry.
The big two. And a lot of cloud engineers assume they can treat both platforms the exact same way when migrating, but their underlying philosophies are completely different.
Right. I mean, we all know the basic facts, like AWS uses virtual private clouds, or VPCs, and Azure uses virtual networks, or VNets. But what is the actual philosophical difference in how you build with them?
It really comes down to their origins and how they handle trust. AWS was born out of Amazon's e-commerce needs, right? Operating in the hostile environment of the public internet.
Oh, yeah. The Wild West.
Because of that, its default mindset is zero trust. When you spin up an environment in AWS, you get a completely isolated, locked-down space. Nothing can talk to anything else unless you explicitly write a policy granting permission.
Got it. And Azure.
Azure, conversely, was born from Microsoft's enterprise IT background, heavily rooted in Active Directory. Its default philosophy is much more about integration.
Okay, so it's friendlier internally.
Exactly. It acts as an extension of a secure corporate network, where resources are attached to virtual networks with a focus on unified management and identity-based trust.
That reminds me of, well, it's like AWS gives you a completely empty concrete bunker and hands you a drill to make your own doors.
Yes, perfect analogy.
And Azure gives you a corporate office building where your ID badge already opens certain hallways.
That's exactly it. And that architectural mindset completely changes how a team approaches security and scaling.
But organizing the servers is really only one half of the equation, right? Organizing the actual data the AI consumes seems like a much harder problem.
It is, and it's the subject of our next article, which looks at the failure of traditional data visualization. Specifically, it compares dashboards versus ontologies.
Dashboards versus ontologies? Okay.
Yeah, the author argues that dashboards have become an incredibly passive tool. You look at a bar chart, you see that user retention dropped by 10%, and then you just close the tab.
Because a dashboard is just a visual endpoint. It's a dead end. But how is an ontology actually different? Isn't it just another way to visualize the same data on a screen?
Not at all. The mechanism is entirely different. A dashboard just plots numbers on an axis. An ontology is essentially a knowledge graph.
A knowledge graph. Okay.
It maps out how your business concepts actually relate to each other through causality. It defines the relationships. So it explicitly links the concept of a customer to a server node, which is linked to a downtime event, which is then linked to a support ticket.
So instead of just seeing a drop in retention on a generic graph, the ontology maps the ripple effect.
Exactly.
It shows that a specific server outage caused a spike in support tickets for a specific tier of customers. It provides the why instead of just the what.
You nailed it.
But why is this so critical for AI specifically?
Because large language models cannot infer complex business rules from a static two-dimensional dashboard. If you want an AI to actually reason about your company's unique data, it needs an ontology to perform multi-hop reasoning.
It has to connect the dots.
Right, it needs to follow the nodes to understand cause and effect. If you don't map those relationships, the AI will just hallucinate answers based on raw, disconnected data points.
That makes total sense. But to run multi-hop reasoning over massive corporate knowledge graphs, you need serious hardware. I mean, all this data mapping and AI computation has a massive physical footprint.
Oh, massive. The physical reality of AI is driving market shifts that are just hard to overstate right now.
What kind of shifts?
Well, we have an article breaking down the incredible rise in the valuation of Qiita.
Right.
And to give some context to our global listeners, Qiita is a Japanese semiconductor manufacturing company.
Right.
Recently, their market cap actually surpassed Toyota in Japan.
Wow.
Yeah, that is a monumental shift in the industrial landscape, moving from automotive dominance to semiconductor dominance. And what Qiita manufactures is NAND flash memory.
Wait. Everyone constantly talks about NVIDIA GPUs driving the AI boom. Why is flash memory suddenly eclipsing auto manufacturing? I thought AI required raw processing power, not just storage space.
That's a common misconception. The GPUs are the processors, yes, but they suffer from a massive bottleneck when it comes to memory. Modern AI models, especially mixture of experts models, are absolutely enormous.
Like how big?
We're talking hundreds of gigabytes of weights. They cannot fit into expensive, temporary DRAM. At the same time, traditional spinning hard drives are just far too slow to feed data to a GPU.
So NAND flash memory sits right in the middle.
Exactly. Furthermore, when you are training a trillion parameter model across thousands of GPUs, hardware inevitably fails. A GPU will crash.
Oh, sure.
To prevent losing weeks of expensive training time, the system performs what is called checkpointing.
Oh, so it takes a snapshot of the entire model's state every few hours so you can recover it if, like, a server catches fire.
Yes, and checkpointing requires dumping terabytes of data simultaneously and rapidly. You need vast arrays of NAND flash to handle those incredible write speeds. Qiita is thriving because AI data centers require an absolute ocean of persistent, fast, long-term memory just to keep the GPUs from sitting idle.
That's fascinating. And that fast storage layer is what makes entirely new software paradigms possible, right? If the AI can read from memory fast enough, it doesn't just have to be a chatbot. It can become an autonomous agent.
Which perfectly frames our final article, covering the announcements for the AWS Summit New York 2026.
Nice.
The standout technology discussed there is Amazon Bedrock Managed Knowledge Bases, specifically a feature called agentic retrieval.
Okay, agentic retrieval. How does that actually differ from standard retrieval augmented generation, or RB? Because right now, RAG just means letting the AI read a reference document before it answers your prompt.
Right. Standard RD is very linear. You ask a question, the system does a single keyword or vector search, feeds the top 5 paragraphs to the LLM, and basically just hopes the answer is in there.
Kind of like a superpowered Command F.
Exactly. But agentic retrieval uses a completely different mechanism, often based on a framework called React, which stands for reasoning and acting.
Okay.
The AI acts like an investigator, independently playing a multi-step search strategy.
So it doesn't just search once. It searches, reads the result, realizes it is missing the second half of the equation, formulates a completely new query on the fly, searches again, and then synthesizes both results.
That is exactly what it does. It uses the ontology we discussed earlier to navigate the corporate data.
Oh, I see how it all connects now.
Yeah, it might pull a Q3 revenue report, realize it needs the Q3 marketing spend to calculate ROI, query their database a second time for those specific marketing figures, do the math, and then generate a final answer.
That is incredible.
And crucially, it provides exact citations, pinpointing exactly which document provided which piece of data.
That's huge for enterprise trust.
It really is. The tech industry is moving toward what the author calls compounding momentum. Autonomous agents can now safely interact with secure company data, reasoning through complex problems step by step, rather than just doing simple lookups.
Man, it really is a complete stack when you look at it. It starts with recognizing the physical reality of NAND flash memory in data centers, which enables the speed required for agentic retrieval.
Yep.
That retrieval only works if your data is structured with an ontology. That ontology has to be hosted on an infrastructure built with a deliberate architectural mindset, whether that's AWS or Azure. And building all of this requires a new generation of developers who don't just rely on AI to write syntax, but who actually understand the philosophy of system design.
You just cannot treat the modern tech stack as a magic spell.
Yeah.
You have to understand the mechanisms at every single layer. Otherwise, you're just building new, more complex forms of lava flow.
Well said. Thank you for joining us today for this deep dive into the source material. Be sure to subscribe and like the show if you haven't already. We will be back tomorrow with a brand new catch-up on dev trends on the go, bringing you more fresh picks.
And as we wrap up today, consider this. In a world where machines can execute perfect multi-step logic, navigate massive knowledge graphs, and write flawless syntax in seconds, what is the unique taste, philosophy, and responsibility that you bring to your engineering team today? What is the human element you are providing that a machine simply cannot replicate?
Something to think about. Have a great day and happy coding.